Hi, this is the Channel 31 News. Our topic today is the galaxies in the universe. I'm Rachel and this is Christian.
We have two special guest speakers with us today. Their names are Eric and Ryan. They're astronomers, or the scientists who study stars, with Rachel with some news.
When you see the hazy band of light across the sky, Christian, can you guess what it is?
I believe it's a Milky Way.
Yes, the Milky Way. When you see this, you're looking at our galaxy from the inside. It's an awesome sight, but you can only see it when you're away from city lights and moonlight.
That's awesome. Let's bring in our guests, Eric and Ryan.
So guys, how do you discover the Milky Way?
Well, we can't really see it because we are on the inside. So all we see are bands of stars. We can't tell how big it is or the Earth's location in it. I am one of the astronomers destined to figure this out.
Well, how do you know what stars are in the galaxy?
There are variable stars, which are the giant branches of the Hertz-Sprung-Russell diagram. In the galaxy center, RR Lyrae variables have periods of pulsation between 1.5 hours and 1 day with the same luminosity.
Okay, so you're saying that you can use the RR Lyrae to determine the distances to the globular cluster.
Yes, that's exactly what I'm saying. Other astronomers have discovered that these clusters are located very far from our solar system, and that their distribution in space is centered on a distant point 28,000 light years away.
What else do astronomers know?
They also know that the global clusters are orbiting the center of the Milky Way.
That's cool. Now tell us about the shape of the Milky Way. What have astronomers found about that?
We astronomers use radio waves to map the galaxy and its shape. That is because radio waves can penetrate the interstellar gas and dust without being scattered or absorbed.
Oh, so what you're saying is astronomers just like you use radio waves to map the shape of the galaxy because they are penetrate the interstellar gas and dust without being scattered or absorbed.
Exactly. Now there's a type of arm, such as a spiral. Knowing that our galaxy has a disc-like shape with a central bulge, astronomers at our base have speculated that it might also have spiral arms.
Was this difficult to prove, speculating that it has spiral arms?
Yes, because we have no way to get outside of the galaxy and look down at the disk. We have used hydrogen atoms to discover these spiral arms.
Whoa, so that had to be been difficult since we live inside the galaxy and all. Did you see the hydrogen atom?
Yeah, tell us why you used hydrogen atoms instead of any other element.
Well, hydrogen atoms in a very low density gas can emit radiation at a wavelength of 21 centimeters.
Okay, we've been talking about the mass of the Milky Way. When we'll come back.
Get your soft caramel with nugget center surrounded by yummy chocolate. The Milky Way bar, sold in all convenience stores near you.
And we're back. These are some guest astronomers, Ryan, Eric, and so Rachel, can you guess what mass of the Milky Way?
Nope, Eric.
The mass located within the circle of the sun's orbit through the galaxy is about 100 billion stars within the galaxy's disk.
Crazy, 100 billion stars just in one disk.
Yes, and it's about the exact number of times the sun's mass. The galaxy is huge.
What are the stars in the Milky Way?
The halo of the Milky Way contains clusters, the oldest stars. Stars like the sun are composed of 98% hydrogen and helium, where in global clusters there's 99.9% hydrogen and helium.
That's cool. Let's move on to information evolution of the Milky Way. What happened there?
Well, the fact that the halo and bulge are made exclusively of old stars suggests that these parts were formed first. We, therefore, have to hypothesis that the galaxy began as a spherical cloud in space.
So you're saying that the halo has a bulge of old stars, which makes you suggest that they were formed first. Therefore, astronomers at the base suggest that the galaxy began as a spherical cloud in space.
Yes, it might seem confusing, but really, it makes very much sense.
We have one last question before you two leave. What are the main features of maintaining spiral arms?
Well, most of the main features of the galaxy are clearly understood by astronomers. We just can't figure out the way in which the spiral arms are maintained.
Are there any theories as to why you can't figure it out?
Yeah, we have two theories, starting with the first one. There's a kind of wave called a spiral density wave, which is responsible. The second one is the spiral arms are not permanent structures, but instead are continually forming. That's what creates supernovae explosions.
Far out. I think the second theory sounds more reasonable. Well, Eric and Ryan, thank you for coming to the show. We learned a lot about the Milky Way galaxy, didn't you, Christian?
Yeah, thank you for joining us in Channel 31 News. This is the Galaxy Universe. See you next time.
Bye, everybody.